Okay, so the next part of curve sketching is then to look at the first derivative and second derivative information. So my first derivative is going to come from noticing that I have a variable divided by a variable. So the only way to find that derivative is with the quotient rule. So setting up my quotient rule, I will have the 2x minus 8 as the top function, and then the 8x minus 6 as the bottom function. Their respective derivatives, this is a linear term, so that will go to the coefficient. The negative 8 is a standalone constant, so that goes to 0. Similarly, 8x is a linear term, so that goes to 8. The negative 6 goes to 0. Now, remember with the quotient rule, we do our crisscross, starting with the bottom, beginning with the bottom, and then we put that over the bottom squared. So my first derivative will look like now. Another helpful thing about the quotient rule, if you happen to notice on the diagonal that you are starting with just one term, put that first so that the distribute step is easier for you. So this is going to be 2 times 8x minus 6. So again, this off diagonal first, and then minus the main diagonal. And again, when I'm looking at the main diagonal, I notice that I have this 8 coefficient that can go in front, and then that will eliminate some of the extra distribute work for me. So I'm going to put that 8 in front just to make the distributing a little easier, and then multiply it by the 2x minus 8. That will then all be over the b squared. The b squared is the 8x minus 6 quantity squared. Now, here we're trying to find where it's increasing and decreasing. That means that our goal is to get one fraction, because we ultimately want to set the derivative equal to 0 and the derivative does not exist. And so in order to do that, we're going to need one fraction, because remember, derivative equal to 0 is where the numerator is equal to 0, and derivative does not exist is where the denominator is equal to 0. So here the simplification is non-negotiable. We must simplify this. And specifically, we will remove our parentheses in the numerator. So a lot of the work will be in the numerator, starting off by distributing, and that will give us, so the 2 times 8x gives us a 16x. The 2 times negative 6 gives us a negative 12. Then we'll distribute the negative 8 to both of these terms. So that's going to give us negative 16x. And then the negative 8 times negative 8 gives us a positive 64. That is then all over the bottom squared. After we remove parentheses, we are then going to combine our like terms. And you'll notice that we do have a 16x and a negative 16x. So those are going to cancel each other out. And then we will take negative 12 plus 64. So again, just the negative 12 plus the 64 to combine those two like terms to 52 over 8x minus 6 quantity squared. All right, so that is our first derivative, simplified to one fraction. Now, once it's simplified, we're finding critical numbers. Why are we finding critical numbers? Because they're asking us about increasing and decreasing. They're also asking us about where is the local min and the local max. So to answer those questions, we need our first derivative and we need to find the critical numbers. So we will set numerator equal to 0 and denominator equal to 0. And again, that tells us where the derivative equals 0 and where the derivative does not exist. You'll notice here when you set the numerator equal to 0, absolutely no x is there to solve, so nothing is going to come from that. Meanwhile, when I set the denominator equal to 0, I can quickly get rid of this square power by taking the square root. I also want to mention that every time that you're working through these, it really will just be what is inside of the parentheses that you'll be setting equal to 0. And that's because we can always quickly eliminate the square power or whatever power we have. So technically you could skip this step and go straight to 8x minus 6 equal to 0, because you were kind of doing this in your head saying, okay, I'm going to get rid of the square by taking that square root. So I'm left with 8x minus 6. I'm going to solve that by adding 6 to both sides and then dividing by 8. So that gives us x is equal to, and then we take out our common factor of 2 there, so 2 times 3, 2 times 4 gives us x is 3/4. Now, technically, this is just kind of for your information. 3/4 is not a critical number. 3/4 is actually not part of the domain. And the reason why it's not part of the domain is because this causes the denominator to be 0. So if you remember when we were talking about critical numbers, we said critical numbers needed to be interior to the domain and where the derivative does not exist or equal to 0. Technically, this is just a domain restriction, and that's what we'll put in on our number line. So when you're working through this, your number line is going to look like 3/4. That 3/4 really comes from the x equals 3/4 is really a domain restriction rather than a critical number. And this is really just kind of a for your information. A lot of students just kind of put down the 3/4 thinking it's a critical number. You'll notice you'll get exactly the same thing. So don't stress but so much about it. But just to be clear, 3/4 is really a domain restriction, and it's a domain restriction because if we set that denominator not equal to 0. Now, specifically when I talk about this, I'm talking about setting the original function, finding that domain of the original function, setting its denominator not equal to 0 will give us that x cannot be 3/4. So you'll remember that when we were drawing our number lines, we always said, you want to draw your number line with the domain. So when I'm drawing the derivative number line, I want to think about what that domain is going to look like. And so when I'm plugging in the 3/4, really that is the 3/4 coming from the domain restriction rather than coming from the critical number. It's not really a critical number. It's really where the denominator is not equal to 0. But either way, you're going to put 3/4 down on the number line. So once we draw that derivative number line, again, we do need to test into our derivative. So you're looking at a first derivative here. And remember I said always go back to right before you set numerator and denominator equal to 0. That formulation right before you set it equal to 0 is the easiest formulation to work with in terms of testing a number. So I am going to work with this 52 over 8x minus 6 quantity squared. And then I'm going to test a number to the left of 3/4. Remember, I am plugging this into the derivative. It's a derivative number line plugging into the derivative. So I might decide to the left of 3/4 that I'm going to plug in 0. That gives us 52 over 8 times 0 minus 6 quantity squared. And that gives us a positive over, and you'll notice here you have quantity squared. Anytime you have something squared, that is always going to be positive. So you have a positive over a positive, which will of course give us a positive. Now, because we are working with the first derivative, remember the first derivative tells us information about increasing and decreasing. So this positive is telling us that we're going up the hill until 3/4. Then we'll plug a number to the right of 3/4. And again, this can be any number you would like that is to the right of 3/4. So I might plug in 1, Sally might plug in 2, Tommy might plug in 3. There's a million different numbers you can plug in. I'm going to plug in 1. I get 52 times 8 times 1 minus 6 quantity squared. And that gives us, again, a positive over a positive. So that's going to tell us that we are continuing to increase. So the picture of this would look like we're going up the hill, then something happens at 3/4, we're going to talk about in a minute, and then we continue going up the hill. So because there is no sign change, we just stay positive, positive, there's no sign change, there would be no relative extrema. You would not have a relative max, you would not have a relative min, because again, we're not seeing that peak or valley. So when you're looking at trying to fill in the answers as they want them, what you would say is you would say that it is decreasing nowhere, because again, all we are seeing is that we're going up, 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 and away. For increasing, be careful here. It's very tempting to want to say negative to positive infinity. That is not true. At 3/4, there is a domain restriction. The function is actually not defined at 3/4. And so for you to correctly report this, you must have two separate intervals. You cannot clump it all together in one interval. So you'll write negative infinity to 3/4 and then union 3/4 to infinity. And remember, we always use parentheses with increasing and decreasing. As we discussed, there's no sign change with this problem. That means there's no relative extrema or local extrema. So there would be none for local min and none for local max.